Alright, so we're going to simplify each of the following radicals. And all we're going to do is we're just going to go and take our radicals and do a prime factor tree. So we're just going to say, well, what times what is 400? So we might start with 4 and 100. And you keep breaking it down until you get your prime numbers, and you circle those as you go. So here I'm just, and you don't have to start with 4 and 100. You could do 40 and 10 if you wanted to. Whatever makes the most sense for you. So here we've got, this one's a pretty long one. So in the end, I end up getting the numbers, I've got 4 2s and 2 5s. So now we're going to look for our pairs of numbers. So you got a pair of 2s, another pair of 2s, and a pair of 5s. So that means when we write out our answer, you're going to write out 2 5s, 2 2s and a 5 on the outside, and then nothing on the inside. That cancels out, and now you end up with 2 times 2 times 5, which gives you 20. Which happens from time to time when your number is going to be a perfect square. So we'll move on to the next one. We got square root of 45. We know 9 times 5 is 45. Break down the 9 because that's the only composite number of the two. So now you're left with 2 3s and a 5. We look for pairs. You write the number once on the outside. Whatever's left stays inside. Got your answer. Question 3. We're going to start with the 90 and then we'll deal with the exponents of the variables after. So here you've got 90, so you would maybe do 3 and 30. Break down the 30. You've got 5 and 6. Circle the 5. Break down the 6. So now you've got the breakdown, all those prime numbers, 4 and 90. I'm going to rewrite my problem. So it's 2, 3, 3, and 5. And then just add in my exponents. So got x to the 5th, y to the 10th. Now, we only have a pair of 3s, so that's the only number that gets written on the outside. 2 and 5 stay in. Next, we're going to look at the exponents to the variables. So what you do is you take your 5 and you're dividing it by 2. So 2 goes into 5 evenly twice, so I'm going to write x squared on the outside, and there's 1x left over. Then I look and divide the 10 by 2. Well, 10 divided by 2 is 5, so it would be y to the 5th. So if there's an odd number of letters, you end up leaving one inside, and then the pairs go on the outside. So your final answer is going to be 3x squared y to the 5th times 10 times the square root of 10x. Alright, and I've got a few more here. Okay, again, with the variables and the number. So we're first going to deal with 80. So you do maybe 8 and 10, and you break those numbers down. Circling prime numbers as you're going. Then we're going to rewrite our problem with all those numbers in there. So you've got the square root of 2 times 2 times 2 times 2 times 5. Then x to the 14th, y to the 21st. Again, you're looking for pairs of numbers. So you've got 2 pairs of 2s. Right? The x's, and that 5, sorry, the 5 stays inside. The x's, we do 14 divided by 2, which is 7. 21 divided by 2 goes in evenly 10 with 1 left over. So on the outside this time we have to multiply those two numbers, and then on the inside 5 and y are left. Right, last one. There's a couple different methods of doing this particular problem. One, you could multiply these two numbers together and then figure out the prime factorization for that. I like to take each one and simplify it individually. So this one I get 3 and 9, 3 and 3 for 9. So then this square root of 27 becomes 3 square roots of 3. The 147, 3 goes into it 49 times. So then we have 7 and 7. So this one ends up being 7 square roots of 3. Now what you end up doing is you'll take the whole numbers, the numbers on the outside, multiply those. You take the numbers inside the square root, multiply them. Then you take the 9, well, the square root of 9 is 3. So you'll have 21 times 3, which is 63. So that's how you do these types of problems. Again, you're just doing prime factorization and then looking for pairs. And then the other couple examples that I wanted to go through real quick was the ones that we took notes on last time. So it's you're adding or subtracting these particular radicals. When you have radicals with the same numbers inside, you can add the numbers on the outside of the radical. So in this case, we end up with 2 square roots of 5x. Do not add these 5x's together. They stay and remain the same. If they're different, then we can't add them. Example 2, we're going to look through the problem, and I see that we have 4b and then 4b. So those two terms I'm going to add together and get 8 square roots of 4b. And then the square root of 3a is just going to remain the same because we don't have anything to add to that. Next one, we can't add them together. So what I'm going to try to do is simplify the square root of 12. So in this case, we got 6 and 2. And then we've got 2 and 3. So when I rewrite this, you'll have 2, 2, and 3. So I have a pair of 2's. So this first part will get rewritten as 3 times 2 times the square root of 3, which is 6 square roots of 3. And if I drop down the other part, we're going to find that now they both have the same square root values. So we can subtract and get 1 square root of 3. So that's just, in a nutshell, reducing radicals as well as combining like terms. Next page is just more of those combining like terms. So please watch your signs. Make sure that your square roots are the same before you start adding them. And if you can't add them together, like for example, if I look at question, put one on here so you couldn't. So like something like this, you wouldn't be able to, number 12, you wouldn't be able to add them right away. You would have to check to see if you could simplify maybe the square root of 20, and so forth. All right, hope this helps.